So this lesson is all about how our body communicates within itself. So the nervous system, we've got your brain, your spinal cord, and your nerves. And they communicate using electrical signals in between them. They can send signals to tissues like your muscles that can act on electrical impulses. There's a bunch of different kinds of tissues in your body that can actually act on these kinds of electrical impulses. Included are all of your muscles, your sphincters in your body. So this could be the sphincter between your esophagus and your stomach. It could be the sphincters, your anal sphincters, or the sphincter at the bottom of your bladder. All of these are controlled by the nervous system. So that is this part. So the nervous system works by two different ways. So we've got our central nervous system and then the peripheral nervous system. The central nervous system is this part here. It is our spinal cord and our brain. Our central nervous system is the bits that make decisions. Okay. Our peripheral nervous system is just there for communication. These are our communication highways in our body. So I am going to run through an example of how our nervous system works. So let's say you are hanging up a picture on the wall and you hit your thumb with a hammer and it is remarkably sore. So the first thing that happens is the nerves in your thumb sends a signal down the nerve pathways to your spinal cord. So it sends a signal of, ow, something happened, all the way to your spinal cord. Your spinal cord then does two things. Your spinal cord controls your reflex reactions, and it can send the information up towards your brain. So the first thing it does is it sends a signal back down to your hand to say, jerk away. So it sends a signal back down the nerves to your hand that activates the muscles to cause a reflex reaction. Okay, so this is that first little bit after you've hit the thumb where you jerk your hand quickly away. That is that reaction. It happens very, very quickly. This is less than 0.2 seconds. After you have hit your thumb, you are already jerking it away. And the idea there is to essentially get you out of that danger as fast as possible. This is what happens when you flinch. If you flinch for some reason, say someone comes up behind you and touches you on the shoulder, you didn't expect it, and you sort of flinch and startle, that reaction is controlled by your spinal cord. It is the reflex reaction that you have. It is sort of the first thing that you do after something has happened. After that, your spinal cord sends this message up to your brain. Okay, so the message has now gotten to your brain. Your brain then sees, oh goodness, okay, the thumb is very sore. We need to do a bunch of different things. So it starts sending signals back down the spinal cord through the nerves to all sorts of different places. It can send a signal to your other hand saying, drop the hammer. You don't want to like hit your finger again. So your other hand can drop the hammer. It can send a signal to your mouth letting you yell ow or any sorts of other words that will make you feel better somehow. It will send signals down through to your thumb again, opening up the blood vessels there so that some more blood can go into the area to start healing your thumb. So that is why after you've hit your thumb with something like a hammer, it starts sort of feeling like it's pulsing. That is because more blood is going to your thumb to try and heal the damage that has happened there. So it does a bunch of things. It sends signals to your other arm. It sends signals to other parts of your body like your mouth or to your legs to say you have to jump or whatever. It also sends signals to your blood vessels so that they can expand so that your thumb can start healing. So there are lots of different things that happens immediately after your thumb has been struck by some kind of thing. Okay. So this is essentially your immediate reactions after something has happened to you. Your nerves immediately send a signal along them to your spinal cord. Your spinal cord sends the signal to your brain. Your spinal cord has some functionality of deciding things and sending signals back. So your reflex reactions is caused by your spinal cord. So this is all of the involuntary reflexes that you would have. So yeah, catching a ball. Say someone is throwing a ball at your face, and the moment your brain registers that the ball is coming, it's going to send it to your spinal cord. But that reaction of keeping your hand up and catching the ball is a reflex reaction. So some reflex reactions can be trained, like immediately catching a ball. Others are ingrained, like flinching away. Say the ball is coming, but you are not a very good sports player. So the first thing you're going to do is, instead of trying to catch the ball like a sports player would, you would duck away so that the ball can go past you. So those kinds of reflex reactions can be trained, but they are just that, they're reflexes. You are not in conscious control of them. Okay. So this is an example of how your nervous system works. It works in lots of other ways as well. Your stomach can send signals to your brain saying that, oh, I just got some food, which is going to let your brain send signals to other parts of your body to start releasing different kinds of digestive fluids, to start your digestive system moving a little faster, all sorts of things. So this is not the only kinds of reactions that we get from our nervous system, but this is a good way of explaining how it works. So continuing on, your endocrine system is the other way of communicating inside your body. So your nerves communicate it using electrical signals. This is very fast signals, and they have very localized reactions. So it could tell this specific muscle to quickly fire and to contract, so that you have that flinching reaction of when you hit your thumb with a hammer. It gives quick actions, but it's also over very quickly, your nervous system's communications. Your endocrine system consists of all of your hormonal glands. Now, disclaimer, this is not just the hormones that we sort of call hormones. This is not just estrogen and testosterone. This is all of the hormones constantly going through your body all of the time. This includes the hormones that regulate your blood sugar levels, the hormones that regulate your digestive system, the hormones that regulate all sorts of different things in your body, the hormones regulating how much antibodies you are making, all sorts of things. These are all part of your endocrine system, and they are all hormones. Adrenaline is a kind of hormone that is in your body. So it's not just things like testosterone and estrogen. Please note. Okay. So your endocrine system communicates by using chemicals. These chemicals are called hormones. They are specifically designed to make certain cells do certain things. So they produce these chemicals, which then travel around your body in your blood. So they don't use the nervous system, which has all of these very, very fast pathways. They travel using your blood, so it's a lot slower reaction. So it would travel in your blood until it reaches the cells. So certain kinds of cells can receive certain kinds of hormones. Most of your cells, say the cells in your arm, in everywhere, would be able to receive certain kinds of hormones from your thyroid that would tell them to turn more glucose into energy, or to, instead of turning the glucose into energy, to turn it into fat so that it can be stored, so that you have some energy for later. So this kinds of cellular actions are controlled by hormones, because the nerves don't reach every single cell. So they're not controlled by nerves. These are controlled by hormones, literally chemicals that go through your body, binds inside the cells to specific receptors that lets the cell do something. Okay. Some kinds of hormones, specifically some of the hormones from your pituitary gland in your brain, would only act on specific kinds of cells. There are some hormones that literally only react to the cells in another gland to tell that gland to start producing a different kind of hormone. So there are lots and lots of different hormones. These organs are all across your body because the only thing they need to be able to work is your blood. Okay, so I'm quickly going to go through a few of these glands so that you guys know what they are. So your pineal gland and your pituitary gland, they are in your brain, and they are there alongside your hypothalamus. Okay, your hypothalamus is sort of in the middle of your brain, and this is where all of the signals from your body, from your spinal cord, etc., comes into the brain. Your hypothalamus then decides what to do with the information. It can send it along to other parts of the brain to be processed there. It can also decide that it needs some kind of hormonal response, which means it's going to start either secreting a hormone to the pituitary gland. The pituitary gland is going to secrete some more hormones to do something else. Or it could decide to do nothing with this information. It can decide to just be like, oh, this isn't really relevant, and leave it be. So your hypothalamus controls all sorts of things like that. Your hypothalamus is also in general called, sillily enough, your reptile brain. This literally takes in the stuff from your body and then decides how to react about it. It could either pass it along or cause some kind of ingrained reaction to take place. Okay, the next gland is your thyroid. So your thyroid sits right about here. So if you feel along your neck, there where your voice box is, it's just below it over there, and it's sort of a butterfly gland around it, and you can actually feel it there. And you will probably know at least one person that has some kind of thyroid problems. You either get hyperthyroidism or hypothyroidism, which means that your thyroid is acting too much or too little. Your thyroid is the organ in your body that regulates your cellular functions. It tells your cells what to do with the glucose that is going through your blood. It'll tell your cells, okay, you need to take in the glucose and turn it into energy, or you need to take in the glucose and turn it into fat, or you shouldn't be taking in glucose right now. It regulates that kind of things. Okay, your thymus is a gland that is stuck right next to your heart. Your adrenal glands are right above your kidneys. This should be fairly obvious. They do something to do with adrenaline. Okay, your pancreas is over here. It helps with digestion. It gives off hormones like glycagon and insulin. So these hormones essentially help your cells in order to process the sugar in your blood or to process the fat that is stored into energy. So you need these hormones in order to have something like that happen. And then your last kinds of glands is your gonads. So this would be the ovaries in a female, the testes in a male, and they secrete things like estrogen, progesterone, and testosterone in order to make certain things happen in your body. But that is not the topic of today's lesson. So here is an example of how your nervous and your endocrine systems work together. So you are walking home one day and a robber jumps out with a big knife and he's like, give me your money. And that is our situation. So the first thing that happens is your eyes see this and it sends all of the signals back to your brain. Your brain gets these signals, it processes it, and it realizes, oh my goodness, there is danger. So the first thing that your endocrine system is going to do is it is going to start with your hypothalamus, and your hypothalamus is going to start secreting a hormone, let me just spell it first, it's going to start secreting a hormone to your pituitary gland. Okay, in the meanwhile, in your brain, what has been happening is it is starting to trigger your fight or flight responses. So it is going to send nervous signals down through your spinal cord to your muscles, tensing them up, making them ready so that you can either fight or run away, the fight or flight response. So your brain is going to send signals down your spine to your muscles so that you can be ready for this fight or flight response. It's also going to send signals to your blood vessels. And what that's going to do is it's going to restrict the blood flow to your digestive system and to all sorts of other systems in your body that is not needed for you to either fight or flight. Then it's going to open up the blood vessels going to your muscles, so that you can be ready to use them to either get out of the situation or to try and punch the guy in the face, which not necessarily a good idea if the guy has a knife. But anyway, so that's what happened with your nervous system. Meanwhile, your endocrine system acts a lot slower because it uses chemicals. These need time to travel through your body. So it has reached the pituitary gland. Your pituitary gland is now going to secrete other kinds of hormones, which is targeted at your thyroid and your adrenal glands, your pancreas, in order to essentially tell them different things. So it's going to send hormones to your thyroid to say, I don't really care about all of this digestive stuff right now. We just need to concentrate on something else. So your thyroid's going to stop secreting hormones. Your pancreas is going to stop secreting hormones too, because it is not necessary right now. What is necessary right now is getting all of your muscles and all of your things to work better. So it's going to send it to your adrenal glands, which is on your kidneys. This is going to take a while because between your pituitary gland and your adrenal glands, if we look over here, your pituitary gland is up here. It's going to have to travel through your blood quite a while in order to reach your adrenal glands. So it gets to your adrenal glands. Your adrenal glands is going to release adrenaline. So adrenaline essentially tells all of your cells in your body to wake up, something is happening. And that speeds up. So we've got adrenaline. That speeds up almost all of your body's functions. You will have heightened senses if you are under the influence of adrenaline. You will see slightly better. You will smell quicker. You will feel sort of very ready to do something. If someone touches you, then you are going to have the biggest fight, flight, jump in your life. But this is adrenaline. It wakes up your whole system very, very quickly so that you can start being ready to do things. Okay. So we've got some adrenaline running through our system. This goes to our cells. Our cells are going to start rapidly making energy so that we are ready for this big thing that is going to happen. So your cells, especially your muscle cells, are going to be making lots of energy so that you can essentially have a good reaction. You are ready for this whole reaction. So that is adrenaline. So now this whole situation is being solved somehow. Say a policeman has rocked up or something, and the robber is caught, and you are now fine. The problem is, because hormones and our whole endocrine system works a lot slower than nerves, you are still going to have some adrenaline running through your system, even though it is not needed anymore. So essentially what's going to happen is your brain is going to register, oh, the danger is past. Your hypothalamus is then going to stop making the hormones that it was making to alert the pituitary gland. Once the pituitary gland no longer gets these hormones, this takes a while because there's still some of this running through the bloodstream. Once it doesn't get these hormones anymore, it's going to go, oh, okay, I can stop now. So it's going to stop sending hormones to the adrenal glands. There's still quite a bit of this hormones running through your blood, so this is going to take a while before your adrenal glands stops producing adrenaline. Once they stop producing adrenaline, there's still some adrenaline running through your system, still keeping you on that sort of semi-high state so that you can do something. So this takes quite a while. For it to start happening can take about 20 seconds. For it to stop happening can take 20 to 30 minutes. So this is a very slow kind of response compared to what our nerves do. But it's a very, very important kind of response because your nerves can just act on things that can take electrical impulses, your muscles, your sphincters, and other nerves. That's all they can do. The chemicals can do a lot more, but it takes slower and it's a lot more widespread of a reaction. It also takes a lot longer to stop. So this is your nervous and your endocrine systems, how your body is communicating inside of it. So yes, that is essentially today's lesson. Okay. So I hope you guys learned something about this. You guys don't need to know all of the names of the glands. Okay. The important ones that you guys need to know is the pancreas, the adrenal glands, and then the pituitary gland and the thyroid. That is your most important glands that you guys need to know. The rest is just knowing sort of how the endocrine system works. It works using chemicals. And in your nervous system, this is fairly easy. You need to know about your brain. You need to know about your spinal cord. You need to know about the nerves. But this is fairly self-explanatory. Okay, so that was your endocrine, your nervous system, essentially how they work. So